This video is about Pythagoras' theorem, looking at 3D questions. So I got 3 different types of style ones and just showing you in different views of what they could ask. Okay, so key points, you need to know what Pythagoras is to start off with, and you need to know and be able to use it with 2D shapes. Most people would have seen that it's a squared plus b squared equals c squared, or it's a squared plus b squared equals h squared. So there's 2 different versions of this. H squared just stands for the hypotenuse. We tend to use it because it stops the confusion when you're going on to trig. Other things that you need to understand is diagonals within rectangles, okay, because we're going to be looking at that in this scenario, especially where we're looking at cuboids, finding the diagonals through that as well, and being able to vision 3D objects. This is the first question. Okay, so we've got a cuboid in front of us and we've been given some sides already. We need to calculate the length of AG, which they've shown us that's dotted through. Now, this is quite a nice question because even though we've got the line across, we actually have a right angle triangle, which I'm going to show you now. So all I've done is covered it in pink, just nice and pretty. Okay, so you can see that by here is actually the base of that cuboid. So the base of the cuboid, like so, and where that line, so if you can imagine this is A, this is B, and this is C, it cuts right across here. So this is making our first diagonal. So the first thing I would do is length of AC. And that's going to be 5 squared plus 7 squared. And so let's work that out. That gives me 74. So AC is equal to the square root of 74. Keep this in third form, okay, because you are doing the calculated paper. It's so much easier to write a third in than loads of different numbers. Just makes it a lot easier. So if we think that this line now is root 74, we've got the height of A and E. So it's the same on the other side. So the height there. So length of AG. So this time we're going to be doing 74 squared plus 3 squared, and that's going to give us the length of that. So essentially 74 plus 9, which gives you 83, and then the square root of 83. Now that's 9.110433, blah, 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 blah. And we need that to 3 significant figures. So 9 is our first significant figure, and then 1, 1. And then because we are working in centimeters, I would even then chuck that in. And that's the end of the first question. Next question, so pause it if you need to. We're going to go through this. So it says here on the cube with an edge length of x, one diagonal is shown. Circle length the centimeters of the diagonal. Similar problem, if it's a cube, we know this is x, this is also x, this is also x. And it's same vision in that triangle along the bottom. So the first bit, if I call that A and B, just to make it easier for me, and I'm going to call that C, because they're the ones I'm focusing on here. So AB length would be x squared plus x squared. So that gives us 2x squared. So the square root of 2x squared. And then BC length would be the square root of 2x squared plus x squared, which would then give us, cancels out, so 3x squared. So our final answer, BC, would be the square root of 3x squared. And ooh, that's a little bit mean. Because it's also brought in indices rules on this question, which I just had to double check. Sorry, it took a little second then. Because we got this is also, we could write this as 3x squared to the half using your indices rules. A little bit mean, this question. Now, I can't square root the 3, so I'm just going to leave that as 3. Remember when it's in brackets, we technically times them. So 2 times a half would just give us 2 over 2, which gives us 1. So I can write 2 over 2 if that helps. So it's just going to move this to the 1. And that's separate because it's no longer in it. So that's why that is your answer. That was a very nasty question, but at the end, just be careful with your indices rules there. So there we go. Last one. So it tells us AH. Hope you like the sound effects. Is 11.3. Calculate the lower bound for the length of the edge of the cube. It's the nearest millimeter. So if it's the nearest millimeter, so actually it's going to be looking at 2.5 if it's the lower bound. Yep. Let's have a look at this then. So it's a cube. So when we know with the cube, we're actually following that same rule that we just looked at. So if we have x and x, just putting a known here, that would give us 2x squared, square root of that, times by x, which is what we've just done. So it's this nice follow-on question, isn't it? So we know the answer to this at the moment is 3x is equal to 11.25. So therefore, x needs to be 11.25 over root 3. I'd love to say this is like one of the more difficult questions that you probably get asked on the paper. You see something like this, I feel like it would be them really testing you out. So that would then give me 6.49, which I think is 495. My bad. To the nearest millimeter, so 6.5.